Somebody asked me last month what a safe number of concurrent requests is, and I gave them the useless answer, which is that it depends. So here is a useful one instead. On one target, last year the number was 2. Dang. 2 requests in flight at a time across the entire job. Anything above that and the error rate started climbing inside an hour. On a different site the same month, I held 90 in parallel for 6 days and nothing ever complained. Same scraper, same addresses, same code. Why I get to say that? I sell the addresses, SIM cards on Singapore carriers, modems on a shelf in my flat, roughly $10 a month per line in carrier data, and another $50 in depreciation on the modem itself. I also run my own scrapers through those lines, which is how I find out what the product does under load before a customer has to tell me. So I have a commercial reason to quote you a big number. More concurrency reads as more lines sold. I quote the small one because a buyer who takes 20 lines for a job that needed 4 cancels in month 2 and posts about it. The number belongs to the target, not to you. Your safe rate is a property of the thing you are pointing at. It depends on what that site runs in front of itself, what its own traffic normally looks like at that hour, and how close to its own capacity it already is when you turn up. That last part moves during the day. A target that shrugs at 30 in parallel at 3 in the morning local time can be sitting at its limit at 9, and when something has to be shed, it will not be the traffic that looks like paying customers. Which means anybody quoting you a fixed figure that holds across all targets is guessing, including me. The 2 and the 90 above are facts about 2 specific sites in 2 specific weeks, and neither one transfers to yours. Work out how little you need. Start from the deadline rather than the dial. You have some amount of work and some window to do it in. Divide one by the other. That is your required rate, and it is almost always far below the number people reach for. Say 100,000 pages and 1 day to fetch them. That is about 70 requests a minute, a bit over 1 a second. If a page takes 2 seconds to come back, 3 requests in flight covers it with room left over. People running that job open 64 threads. I have watched somebody set concurrencies to 200 for work whose real requirement was 4 a second because 200 happened to be the value in the example they copied from. The question worth asking is what the slowest finishing rate looks like. Run that one and keep the difference as headroom. Headroom is the whole point. A job at 40% of what it could do absorbs a slow hour without anybody noticing. A job pinned at its ceiling turns a slow hour into a missed deadline, and then somebody panics and turns the dial up. Per address is the dial that matters. 20 threads spread over 20 address behaves nothing like 20 threads on one address, and the total concurrency figure hides that difference completely. The site never sees your job, it sees each address on its own, and it counts per address. There is nothing in a request anywhere that says these 40 connections all belong to the same person. So the number to write down is requests per address per second, and everything else is bookkeeping. One thread on each of 20 addresses looks like 20 ordinary visitors. 20 threads on one address looks like one visitor with 20 hands. This is also where people misprice their supply. Somebody asked me for 2 lines and wants 60 requests in parallel, and the arithmetic on that is 30 per address, which no residential connection on earth produces. The fix is usually more addresses at the same total rate. That costs money, which is exactly why I want you to notice who is telling you, and why I would still rather you bought the number the job needs. A perfectly even rate is itself a signal. Here is the part that catches people out. A request every 2 seconds, exactly, forever, is not a pattern any human produces. Nothing with a person behind it holds a flat interval. People read, pause, open a second tab, wander off to make coffee. An interval that never varies is one of the cheapest things in the world to spot, because you can find it with a standard deviation and nothing cleverer. So put variance in deliberately. A fixed delay with a tiny random tail bolted on does not count. You want a spread wide enough to look like reading time. So if your mean gap is 2 seconds, let the real gaps run anywhere from half a second to 5. This costs you almost nothing. The mean rate stays where it was. Only the shape changes. Variance protects you a second way too. 2 workers on 2 addresses with identical timing correlate perfectly, and correlated timing across a pool is how several addresses get read as one operator. Bursts are worse than the average suggests. 200 requests spread evenly across a minute and 200 fired in 4 seconds have the same average. They do not land the same way at all. Rate limiting mostly runs on short windows, a few seconds, sometimes a minute. It has no interest in what your hourly average was. So a job that sleeps for 50 seconds and then dumps everything it owes gets refused, while the same volume dripped out survives the whole night. Subbatching does this to people without them ever noticing. You collect a page of links, fire the whole page at once, wait for the next page. The traffic comes out in lumps with gaps between them, and every lump is a burst. Space inside the batch. The queue should hand out work at a rate, and the worker pool should be starved by that rate instead of by how fast responses happen to come back. Finding your actual ceiling? You find it by walking up to it slowly and stopping before you touch it. Start deliberately low. 1 request in flight per address, a wide random gap, an hour of real work against the real target. Write down 3 things: median response time, the 95th percentile, and the share of responses your parser could genuinely read. Then double it. Another hour, same 3 numbers. Keep doubling until one of those numbers moves, and one of them always moves before anything gets blocked. Then step back down 1 rung and sit there. That is your number for that target this month. The whole exercise takes a day and saves the week you would otherwise spend guessing and rewriting. Response time is the early warning. Everybody watches error rate. Error rate is the late signal. What moves first is latency. A target under strain starts answering more slowly before it starts refusing, because queuing is cheap for it and refusing is a decision somebody had to configure in advance. So if your median climbs from 400 milliseconds to 900 while you went from 8 in flight to 16, you have found the ceiling already. Nothing has failed yet. That is the entire point. The 95th percentile moves earlier and moves further, and it decides how much of your worker pool is sitting in a wait state at any given moment. Back off at degradation well before the first block. Once you are in whatever penalty box the site keeps, coming out of it takes considerably longer than the time you saved by pushing, and block is rarely a clean signal anyway. Plenty of sites quietly return a page with nothing on it or serve something stale out of cache, and a scraper counting status codes will report perfect success while the parser writes empty rows all night. The trap that gets everybody: your target gets slow. Maybe you caused it, maybe their database is having an afternoon. Either way, your throughput drops and your deadline has not moved. So you raise concurrency to compensate. That is the single most reliable way I know to turn a working job into a blocked one. The arithmetic is against you before you start. A slow target means every request holds its connection longer. So at the same thread count, you already have more requests in flight than you did an hour ago. Raising the thread count multiplies a number that went up on its own. And if you were part of the reason it slowed down, you have just added load to something already struggling, which makes it slower, which makes you add more. That loop runs to its conclusion in about 20 minutes. When a target slows down, slow down with it. Finish late or finish tomorrow. What I tuned wrong. I had a job pulling roughly 140,000 pages a night off one source across 8 mobile lines, 5 threads on each. It ran clean for about 5 weeks. Then the window moved. Same volume, 6 hours instead of 9. I went to 12 threads a line, watched it for 20 minutes, saw no errors and went to bed. It had been failing since the second hour. Not with errors. The responses came back looking healthy, and my parser was finding about a third of the fields it used to, because the source had started serving a lighter version of the page to whatever it had decided I now was. 3 nights of that went into the database before anyone spotted it, and cleaning it up took longer than the job it was meant to speed up. 2 separate mistakes there. I watched for 20 minutes on a change whose effects took 2 hours to surface, and I was asserting on status codes rather than on content, so my monitoring said fine the entire time. I had also multiplied by 2 and a bit when the work needed 1.5. Going from 9 hours to 6 is a 50% increase in required rate, and I went from 40 in flight to 96. Fifth ticks had nothing to do with threads. I went back to 5 a line and bought 4 more lines, about $46 a month in SIM and modem terms, and hit the 6-hour window at the same per address rate that had worked for 5 weeks. What I cannot tell you your number, and neither can anybody else selling you addresses. I do not know your target, I do not know what it runs, and I have no idea who else is pointed at it this week. Anyone who quotes a figure without knowing those things is quoting whichever figure sells the most lines. The ceiling moves under you as well. A site that took 30 in parallel in March can take 6 in August because they changed a vendor, and the only way you find out is by measuring again. So measure on a schedule. Once a month is plenty for a stable source. Keep the numbers somewhere you can put them side by side, because a slow drift is invisible unless last month is written down next to it. The ladder I actually run, the numbers worth recording at each rung, and what a degrading target looks like before it starts refusing you, are at proxyscraping.org. Subscribe for more on scraping with